The farthest known fast radio burst is surrounded by a cluster of 7 galaxies, resembling a blob-like structure. Greetings and salutations to everyone. In today's video, we will be delving into the fascinating subject of the origin of the most powerful fast radio burst, FRB, ever detected. Astronomers have successfully traced this extraordinary event back to a cluster of at least 7 galaxies, thanks to the remarkable imagery captured by NASA's Hubble Space Telescope. These galaxies are visibly interacting with each other, potentially indicating an impending merger. Such gatherings of galaxies are exceedingly rare and may have created the ideal conditions for the occurrence of the FRB. This unexpected revelation poses a challenge to existing scientific models regarding the generation and source of FRBs. Notably, this study received support from esteemed organizations such as the National Science Foundation, the David and Lucille Packard Foundation, the Alfred P. Sloan Foundation, the Research Corporation for Science Advancement, and NASA. Without further delay, let us now embark on our discussion. During the summer of 2022, astronomers made a groundbreaking discovery when they identified the most potent fast radio burst, FRB, ever recorded. Not only was this FRB incredibly powerful, but it also originated from a location that can be traced back to the halfway point of the Big Bang, making it the most distant FRB ever detected. The birthplace of this extraordinary object has been determined by a team of astronomers from Northwestern University, and it is quite intriguing to say the least. By utilizing visuals captured by NASA's Hubble Space Telescope, the scientists were able to track the origin of the FRB not to a single galaxy, but to a cluster of at least 7 galaxies. These galaxies within the assemblage seem to be engaging with each other, potentially even heading towards a future merger. The occurrence of such galaxy groups is uncommon and may have created circumstances that sparked the FRB. The surprising discovery has the potential to question existing scientific models regarding the production and origin of FRBs. The imaging provided by the Hubble telescope is crucial in unraveling the enigma surrounding the origin of this fast radio burst, FRB. If it weren't for the Hubble's observations, we would still be left wondering whether this FRB emerged from a single massive galaxy or from a complex interacting system. These unconventional environments, which pique our curiosity, serve as catalysts for deepening our comprehension of the perplexing nature of FRBs. During the 243rd meeting of the American Astronomical Society in New Orleans, Louisiana, Gordon will be delivering a presentation titled "Revealing the Environment of the Most Distant Fast Radio Burst with the Hubble Space Telescope." This session, focused on high-energy phenomena and their origins, is scheduled for Tuesday, January 9th at 2:15 p.m. CST. Gordon, a graduate student in astronomy at Northwestern's Weinberg College of Arts and Sciences, is under the guidance of study co-author Wen-Fai Fong, who holds the position of Associate Professor in Physics and Astronomy. Both Fong and Gordon are affiliated with the Center for Interdisciplinary Exploration and Research in Astrophysics, Sierra. FRBs, or fast radio bursts, are powerful radio signals that flare up and vanish in a matter of milliseconds. These bursts release more energy in a single burst than our Sun emits over an entire year. The recently discovered FRB, named FRB 202-20610A, broke records by exhibiting even more extreme characteristics than its predecessors. In addition to being 4 times more powerful than nearby FRBs, this particular FRB holds the distinction of being the farthest one ever detected. The event, known as FRB 202-20610A, occurred when the universe was a mere 5 billion years old, which is noteworthy considering that the current age of the universe is 13.8 billion years. During the initial examination, it seemed that the explosion had its source in a shapeless, unidentified mass, which astronomers initially believed to be either a solitary, asymmetrical galaxy or a cluster of 3 remote galaxies. However, the Hubble telescope's recent high-resolution images propose an intriguing possibility. The amorphous blob might actually consist of at least 7 galaxies in remarkably close proximity to each other. In fact, these galaxies are so tightly packed that they could easily fit within the confines of our own Milky Way. According to Fong, there are indications of interactions among the members of the group. This implies that they may be engaging in material exchange or potentially moving towards merging. Compact groups, which are extremely uncommon in the universe, represent the most densely populated structures on a galactic scale. According to Gordon, this particular interaction has the potential to initiate episodes of star formation. This observation suggests that the source of FRB 202206110A may be linked to a relatively recent group of stars, aligning with our previous findings regarding other FRBs. The identification of host galaxies for FRB events has been limited despite the large number of discoveries, explained Yuxin Vic Dong, a co-author of the study and an astronomy PhD student in Fong's lab, as well as a member of Sierra. Among the few that have been identified, only a handful have been found in dense galactic environments, and none have been observed in such a compact group. Therefore, its place of origin is truly exceptional. Since their initial detection in 2007, astronomers have detected approximately 1,000 FRBs, yet the sources responsible for these intense bursts of energy remain elusive. While the scientific community has not yet reached a consensus on the specific mechanisms behind FRBs, there is general agreement that they involve a compact celestial object, such as a black hole or neutron star. Through the unveiling of the genuine essence of FRBs, astronomers have the potential to gain insight not only into the enigmatic phenomena, but also into the fundamental nature of the cosmos. After embarking on an intergalactic journey spanning billions of years, the radio waves emitted by FRBs eventually reach our telescopes, having encountered various substances throughout their passage across the universe. The transmission of radio waves, specifically, is susceptible to any obstructing substance that lies in its path, from the location of the FRB to our position, explained Fong. This implies that the waves must traverse any cluster of matter surrounding the FRB site, navigate through its host galaxy, traverse across the expanse of the universe, and ultimately endure passage through the Milky Way. By analyzing the time delay present within the FRB signal, we are able to ascertain the cumulative effect of all these factors. In order to further investigate the origins of FRBs, astronomers must continue their efforts to detect and analyze a greater number of these phenomena. Thankfully, advancements in technology are continuously enhancing sensitivity, leading Gordon to confidently predict that additional detections, including the capture of exceptionally faint FRBs, are imminent. Dong explained that by obtaining a larger sample of distant FRBs, researchers can delve into the study of FRB evolution and their host properties. This can be achieved by establishing connections with nearby FRBs and potentially identifying additional peculiar populations. According to Gordon, the sensitivity of FRB experiments will be heightened in the coming years, resulting in a remarkable surge in the detection of FRBs at such vast distances. The unique nature of this particular FRB will soon be unveiled, allowing astronomers to gain valuable insights into its extraordinary environment. Funded by the National Science Foundation, award numbers AST 1909358, AST 2047919, and AST 2308182, the David and Lucille Packard Foundation, the Alfred P. Sloan Foundation, the Research Corporation for Science Advancement, and NASA, award number GO 17277. The research, titled "A Fast Radio Burst in a Compact Galaxy Group at Z tilde 1 inch," was conducted. Initially detected by astronomers using the Australian Square Kilometre Array Pathfinder radio telescope in Western Australia, the origin of FRB 202206110A was subsequently verified using the European Southern Observatory's Very Large Telescope in Chile. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.